Hello, good morning, and welcome to Science E-Learning Academy. In today's tutorial video, we shall be looking at vector addition and subtraction. So we look at vector addition and subtraction, vector addition and subtraction. So we shall as well look at vector multiplication. So given that a equals axi plus ayj plus azk, and b equals bxi plus byj plus bzk, we can add or subtract these two vectors. We can add or what? Subtract these two vectors, so that we have, if you want to add this, you add, this is in I units, this is in j units, this is in k units. You add I to I, j to j, and k to k. So what do we have now? We're now having ax plus or minus. You can perform either addition or subtraction. So you have bx, this is I, plus ay plus or minus byj, plus have az plus or minus bzk. So we shall be using this to solve an example on vector addition and what? Subtraction. So given that if a equals 3i minus 4j plus 0k, b equals 2i plus 3j plus k, and c equals 4i plus 2j minus k, we can find I, a plus b, we can find II, 2a minus b, we can find III, a plus b minus 2c. So this is the idea of vector what? Addition. This is vector subtraction. When we multiply a vector by a scalar, we can, when we multiply a vector by a scalar, sorry for that, this is a vector and this is a scalar. So when we multiply a vector by a scalar, we can take away a vector b from it. The same applies to this. So when you add two vectors and you multiply a vector by a scalar, you can take it away from the sum of these two vectors. So how are we going to solve this problem? So given that a is this and b is this, then c is this, let us find a plus b. Remember, this is vector in what? 3 dimensions. This is I, j, and k, where the value on the k is 0. Of course, you know that this vector is of this form: a equals a x I plus a y j plus a z k, where we're having negative value here and 0 value here. So how do we add the vectors? How do we add the vectors? How do we add the vectors? To find a plus b, so we have 3i minus 4j plus 0k. We add it to 2i plus 3j plus k. So how do we add it? Add I to I, j to j, and k to k. So a plus b will now be 3i, this is plus 2i, we are done with this. Then we have minus 4j plus 3j, then we have plus 0k plus k. So that we now have 3i plus 2i is 5i. Then we have minus 4 plus 3 is minus 1. So we have minus j. Then you have 0 plus 1. What do you have? 0 plus 1 is 1. So you have plus 1k or plus k. So this is a plus b. So when you add the vectors a plus b, this is what you have. So let us resolve this. 2a minus b. 2a minus b. So 2a implies 2 brackets. You multiply this vector by this scalar 2. So this is 3i minus 4j plus 0k. So that we have 6i minus 8j plus 0k. So we have found 2a, that is this. Let's take away the vector b from it. So we have 2a minus b will now be 6i minus 8j plus 0k. Then we have minus, what is the vector now? We have the vector is vector b, 2i plus 3j plus k. So what do we have here? So we have, this is 6i minus this, minus 2i, this is minus 8j minus 3j, this is plus 0k minus k, and we'll be left with 6i minus 2i is 4i, this is 8 9 10 11, this is minus 8 minus 3 is minus 11j, this is plus 0 minus 1, this is minus k, this is minus k. So this is how to add and what? Subtract vectors. This is how to add and do what? Subtract vectors. Of course, you know that this is let's check if this is correct again. This is 0k minus k. So this is minus 1. It's minus 1 here. So that's why I can write this as minus 1k. So this is that. So this is 2a minus what? B. The same applies here. So what you do is that you add a plus b, you add a plus b, then you find the scalar, you multiply this vector c by 2. So let's even do it. Let's do it. So let me clean this. So let us find I. So a plus b will be, we found it before, a plus b will be, this is 3i minus 4j plus 0k. Then we add it to 2i plus 3j plus k. And we had, this is 5i, this is minus 4j plus 3j, this is minus j plus 0k plus, this is what? K. So let us find 2c. 2c will be 2 brackets 4i plus 2j minus k, so that we have 8i plus 4j minus 2 what? K. So if we now take away 2c from this, what do we have? We say a plus b minus 2c, so that we have 5i minus j plus k minus, this is the 2c now is 8i plus 4j minus 2k. So what do we have? So we have 5i minus 8i, we have minus j minus 4j, then you have plus k, this is, you have, this is minus minus is what, plus, so plus 2k. So what we now have, 5i minus 8i is minus 3i. So minus j minus 4j is minus 5j. This is 1. Okay, so plus k plus 2k is plus 3k. So this is the answer to this. So this is the idea of vector addition and subtraction. So let us look at vector vector multiplication, the idea of vector multiplication. So let us look at the idea of vector multiplication. Vector multiplication. So we shall look at how to find scalar products. Scalar products. You can call it scalar product or dot product. Dot products. Dot products. So if you have two vectors, let's say A and vector B, the dot product of these vectors is written as A dot B. A dot B. So let us find laws that guides dot products. Laws or rules of dot products. Rules or laws of dot products. So we have rules of dot products. Dot products. If you have two vectors, okay, dotting each other is same as this, b dot a, either of the ways. So this is rule number 1. So rule number 2, if you have a vector dotting the sum of two vectors, is same as having a dot b plus a dot c. If you have vectors, two unit vectors, two unit vectors, let's say in ijk, for instance, I dotting itself is 1. The same applies with j dotting itself is 1. K dotting itself is 1. But if it is dotting another unit vector, for instance, you have I dotting j, it is 0. You have j dotting k, it is 0. You have k dotting I, it is what? 0. Again, giving two vectors, giving any two vectors, let's say a and b, where a equals axi plus ayj plus azk, and b equals bxi plus byj plus bzk. So we find out that when we dot a and b, we'll be having ax bx plus ay by plus az bz. So let us give an example to illustrate this. So let's see how this law applies. So given two vectors, 2i plus 5j minus 3k and b equals 3i minus j plus k, we can find the dot product just by saying 2i plus 5j minus 3k, then we dot it with the vector b. This is 3i minus j plus k. And what do we have? So if we dot I with each side, it gives us 1. But if we dot I and j, it gives us 0. So our interest is just this and this, this and this, then this and what? This. So 2 dot 3 is 6. We find the product. I dot I is 1. Is 1. So we are done with this. Then I'll write plus. Before I write plus, let me check what is here. I'll say plus, the product of plus and minus. Plus minus is minus. Is what? Minus. I write it. Then I'll say 5 multiplying, there is 1 here. That is 1 here, invisible 1. 5 multiplying 1 is 5. Then I can now say j dot j is 1. I have it as this. Then I come to this, minus plus is minus. 3 multiplying 1, that is invisible 1. This means 1k. So 3 multiplying 1 is what? 3. K multiplying k is 1. So we now have 6 multiplying 1 is 6. Then what do we have here? We have this is minus 5. This is minus 5, so we have minus 5, and this is minus 3. Minus 3. So we're having 6. This is minus 8. 6 minus 8. 6 minus 8. And what do we have? Because this is minus 5 minus 3. It's minus 8. This is what? Minus 2. This is minus 2 because this is plus. This is plus. So plus 6 minus 8 is minus 2. So you see, we're able to find the dot product of A and what? B. And of course, you see that we neglected the ij. We don't have the values of I, j, k. So dot product of two vectors gives you a scalar. Dot product of two vectors gives you what? A scalar. And this is of this form, as we said, that A dot B is of this form, ax bx plus ay by plus az bz. So you see that we're not having the ijk components here, just as we had here. So let us look at other components of what? Dot products. Other components of dot products. So you should note that when we have A dot B, this is just multiplying two vectors. Multiplying what? Two vectors. Dot product. But when we say, let's say we are multiplying 2 by a vector, so we are multiplying a vector by what? A scalar. This is a vector and a scalar. So what happens when we have two vectors in this manner? We have two vectors inclined at an angle. When we have two vectors inclined at an angle, how do we resolve it? So we have this relationship. So when you are talking about dot products, when you have two vectors, A and B, inclined at angle theta. So from the idea of dot products, we can have that A dot B equals magnitude of A, magnitude of B, cos theta. So when you know the dot product of giving two vectors and you find the dot products, then the magnitude of the vectors, you can find the angle between the vector. You can find the what? Angle between the vector. Also, when you know the magnitude of vector A and magnitude of vector B, and you know the angle, you can find the what? Dot product. You can find the what? Dot product. From this, we can see that the dot product of force and displacement is just a definition of work. Definition of work. You know that work is a scalar quantity. So work is the product of what? Force and what? Displacement. So this is a scalar. So when you have it at this, when it is inclined at an angle, let's say this is a force and this is displacement, we can have it as Fs cos what? Theta. Fs cos theta. Of course, you see that these are vectors. These are what? Vectors. It's of this form. Is of this form. So dot product of two vectors gives you a scalar. So and you should note that two vectors are perpendicular to each other if the dot product is 0. So when you are given two vectors and you find the dot product and it gives you 0, it means that this vector A and B are what? Perpendicular. Perpendicular. So when you have two vectors and you dot it and it gives you 0, it means that the vectors A and B are perpendicular. And of course, you know how to dot two vectors as we have shown before. So let us look at the idea of cross products of vector products. Cross product of vector products. Giving two vectors inclined at an angle, let's say this is A, this is B. From the idea of dot product, we can find the idea of cross products giving this relationship A cross B and having let's say this is A magnitude, this is B magnitude sine theta. So when you know the magnitude of A and the magnitude of B and the angle in between, so you can find the cross product of giving two vectors A and B. You can find the cross products. So what are the rules guiding cross products? What are the rules guiding cross products? Let's look at it. So when you have this is let's say this is the circle, this is clockwise position, this is I, this is J, this is K, vector in 3 dimensions. When I cross I cross J, that is I cross J, it gives us K. Then when we cross J and K, it gives us I, and when we cross K and I, it gives us J, following this method. So when you do it anti-clockwise, in an anti-clockwise direction, you have it as what? Negative. You have it as negative. So that is when we now say, for instance, when we say let's say J plus I, it will give us minus K. For this one, when we say K cross J, it will give us minus I. For this one, when we say I cross K, it will give us minus J. So when you do it anti-clockwise, so these are some of the rules of cross product. So if we have I cross I, it gives us what? 0. Have J cross J, it gives 0. Have K cross K, it gives what? 0. Alright, if you have two vectors and you are multiplying it, finding the cross product is same as having this and multiplying with A. Also, if you have a vector and you are multiplying it by sum of two vectors, the same thing as having A cross B plus A cross C. So we are going to be making use of this relationship to evaluate problems involving cross products. So we can find the cross product, also find the cross product of two vectors using the method of determinant. Let us give an example to illustrate this. But we should know that when you find cross product of two vectors and it gives us 0, it means that the two vectors are parallel. Two vectors are what? Parallel. And three vectors are coplanar if their determinant is 0. So you should know how to find determinants of vectors. Determinants, the idea of determinants. So when you find calculate three vectors, you find their determinant and it gives you 0. It means that the vectors are what? Coplanar. So let us find an example to illustrate this idea of what? Cross product. So we have, if D and E are vectors and we have D to be this and E to be this, we can find the cross product of these two vectors using the method of what? Determinant. Using the method of determinant, and we can find the angle between these two vectors using the relationship involving cross product. And we can also show that when we dot D and this, or E and this, that is perpendicular if it is 0, because when we say that when the dot product of two vectors is 0, it shows that the two vectors are what? Perpendicular. So let us solve this problem before us. So let us use the idea of cross products to evaluate this. When you are given that D equals this and E equals this, finding D cross E. So we use it direct. We are going to make use of determinant method, and we are going to follow this rule. And we know that when we cross I and I, it gives us 0. Cross J and J gives us 0. Cross K and K, it gives us 0. So when we say minus 5 times 7 is minus 35, but when we say I cross I, it gives us 0. So we come to this, we say minus 5 times plus 8 is minus 40. But when we say I cross J, look at it, I cross J is K. So you have K. Then you come to this, we say minus 3 times 4 is minus 20. But when you say, look at the one we are doing here, we say minus 5, we are taking 5 now. Minus 5 times plus 4 is minus 20. Then when we say I cross K, so look at it, K cross I should give us J. So when we say I cross K, it should give us minus J. So it will be in the opposite direction. This is how you take it. When you are done with minus 5I, when you are done multiplying it with the whole of this, then you use 6J to multiply the whole of this. When you are done, use minus 3K to multiply the whole of this. And you'll be left with 48I minus J minus 82K. So this is how to find cross products. This is how to find what? Cross product. Let us see if we can resolve this using the method of determinant. So using the method of determinant, what do we have? So we have that D cross E will be, we have these vectors as, this will be I, J, K. So this will be minus 5, 6, minus 3. This will be 7, 8, 4. So using the method of determinant, we say I, when I take this, I close up this and this. So I take I. So you should revise how to find determinant. We have, this is 6, 8, minus 3, 4. So this is plus, minus, plus. So I'm taking it as plus here. So when I come to J, I'll say minus, look at minus J. Then I'll close here and take this. So I'll have minus 5, 7, minus 3, 4. So I take K is plus K, you have minus 5, 7, 6, 8. So to find this, you say 6 times 4, then you say you say 6 times 4, it will be, I'll just show one. See I, we have 6 times 4 is 32. 6 times 4 is 24. 6 times 4 is 24. You say minus, then you have minus 3 times 8 will still give you 24. So you have I have 24 plus 24, which will be what? 48. So you have 48i. So this is how you are going to do this and how you are going to do that. And you now get that. So you get that D cross E will be 48i minus 5 minus j. When you resolve this, when you resolve the whole of this, it will give you minus j, then minus 82k. So when you resolve this, it will give you 82k. So this is how to find. You see that this one is easier, using the method of determinants to find cross product. You see that this will give you what? Using the method of determinants, this will give you this. So that is the cross product of D and what? E. So we can use the idea of cross product to find the angle between the vectors, just as we are given in the relationship. So what is the relationship? We want to find the angle between D and E. Angle between D and E. So we know. So what we'll be looking at now is angle between D and E. So from this relationship, that D cross E equals D magnitude E magnitude sine theta. So when we make sine theta subject of formula, we have D magnitude, then D magnitude, E magnitude. So from that answer we got before, that D cross E is we got it to be 48i minus j minus 82k. So when we find the magnitude, I have shown us how magnitude is being calculated. So you have it as roots 9029. And when you find the magnitude of this, I multiply it with the magnitude of this, you have square root of you have 9030, which is approximately 1. I have shown us how we can find the magnitude of this. So that is magnitude of D alone. So when you find the magnitude of D, you find the magnitude of E, you multiply it. So you have finally this. So we're now having that sine theta is approximately 1. So we have that theta is sine inverse of 1, which is 90 degrees. So the angle between the two vectors D and E is what? 90 degrees from this relation. So we made use of this because what we have here is cross product. So if it is dot product, we still have another relationship for that. Then the last question we are asked to evaluate is we are asked to find to show that D dots we are asked to show that D dot D plus E is 0. So we're asked to show whether D dot E is perpendicular. So it's perpendicular if the dot product is what? 0. And you find out that when you dot D and this, you get 0. And when you dot E and this, you get what? 0. So we have this already given. So this is, remember, this is multiplication. This is what? Multiplication. This is the cross product we found. So when you dot D and this, you get 0. When you dot E and this, you get what? 0. It means that this vector and this vector are what? Perpendicular, as we said before. In our next video, we shall be looking at the idea of position vector, idea of what? Displacement vector, velocity vector, and acceleration vector. So when we are done with this, we now look at how to find curl of vector field, gradient of scalar field, and divergence of vector field. If you've been blessed by this video, do well to subscribe to our channel for more video updates. Thank you for watching. Good morning.